Of course. Okay, so today I'm gonna give you guys an example. Fx equals x squared minus 6x plus 9. Find the intercept and graph it. Okay, try this example for me. Okay, I'm gonna write down the answer on board. So find the intercept, for example, x-intercept. That means y equals 0, right? Y equals 0. So that means we have x squared minus 6x plus 9 equals 0. That means we're going to solve this quadratic equation, and we're going to use the quadratic formula, right? So a equals 1, b equals -6, c equals 9, b squared minus 4ac, right? So b squared -6 squared times a times 9 equals 0. That means we have one solution, unique solution, okay? We only have one solution because b squared minus 4ac equals 0. So we plug in the quadratic formula. I mean 6 plus or minus 0 should be itself, right? Divided by 2, 3. We got the x-intercept, that is 3, okay? And for y-intercept, gonna be what? X equals 0, right? Y-intercept, x equals 0. So we have what? F0 equals 0, plug in 0 here, right? So we have 0 squared times 6, 0 plus 9 equals 9. Okay. So for the y-intercept, it's going to be 9. Okay, we already find all the x-intercepts and the y-intercepts. Now, graph it. How to graph it? We need a vertex, right? Vertex. In order to graph this quadratic function, we need a vertex. We're gonna use the formula vertex, right? So x equals negative b over 2a. B is what? B is -6. A is 1. So 6 divided by 2 is 3. Negative, negative, positive, right? And for the y coordinate, gonna be F3. Right? F3 plug in 3 here. We're gonna have 3 squared minus 6 times 3. Aha. So we have what? We have the vertex. That is what? 3, 0. Right? 3, 0. 3, 0. Okay, we got a 3, 0. And the interesting thing is what? We need a 3 points, right? We need a 3 points to construct the curve or construct the graph. Here, vertex 1, the y-intercept is 9, right? And the x-intercept, be careful, the x-intercept is 3. And the coordinate is gonna be 3, 0, 3, 0. That is overlapped with the this vertex. So basically, we just have 2 points because for the x coordinate, we got is 3. So x coordinate is 3, 3, 0. Or x-intercept is 3. So 3, 0. Right? This point is 3, 0. So it is overlapped with this vertex. So basically, we just get 2 points. Right? However, we need 3 points to construct the quadratic curve. What we can do? Do you have any idea? We need 3 points. However, here we just have 2 points. what we can do? Aha, that's the strategy we learned before. If I give you a function like that, you can pick the point, pick 3 points. Just randomly pick a point. For example, for this case, I would like to pick a point like x equals 6. Okay, you just randomly pick a point and calculate the y value, and we construct the 3 points. Okay, that's the strategy, like we did before. If I give a function, you just draw a table and pick the point, right? And then connect all the points. That's gonna give you the graph. Okay. So for this case, since we need an extra point, what are we gonna do? Just randomly pick a point, pick an x value. For example, here I pick an x equals 6. Of course, you can pick x equals 5, x equals 4, whatever you want. Just pick one value and calculate it. So here I want to pick 6. We plug in, pick x equals 6. Okay, then I plug in. Okay, we get the value is 9, 36. So now we can draw the picture. We know we have vertex that is 3, 0 is here. And we know that y-intercept is 9. We know the another point is 6, 9. Right? X equals 6, y equals 9. So we connect these 3 points. Okay, that is the quadratic function curve. Okay, 3 points. One of them should be a vertex. Okay, vertex, and we know the vertex is overlapped with the x-intercept, right? Overlapped with x-intercept. What are we gonna do? Just pick an x point. Okay, x point. Okay, so that's what we learned from the last class. Today we're gonna learn a new format of the quadratic function. Okay, quadratic function. So previously, I would like to write down the everything here. So ax plus bx plus c, right? And we have the vertex is negative b over 2a. Axis of symmetry x equals negative b over 2a. And of course, a greater than 0, we have what? We have like that. Right? A less than 0, we have what? We have that. Right? That kind of things. Of course, I mentioned the increasing, decreasing, and domain range, and the absolute minimum. And here, for this case, absolute maximum, right? This kind of properties. And today we're going to learn a new format. This format is here. Fx equals ax minus h squared plus k. Okay, that's a new format. Okay, here is a times x minus h squared plus k. That is also quadratic function. Just write down its different format. And in this format, we know the vertex, be careful, is h and k. H and k, okay? And of course, the axis of symmetry is x equals h. Okay, x equals h. It's always about x coordinate. Okay, x equals h. Now, let's check the graph. If a greater than 0, we still have this guy. The vertex is hk. Okay, that's the first case. Second case, if a less than 0, the same things. Very similar to the previous case. The only thing is now I directly give you the vertex hk. Okay, from this format, we can tell the vertex h and k. Okay, h and k, and the curve gonna be very similar because a is here, right? A is here. We didn't change the a. If a greater than 0, that means opens up. If a less than 0, opens down. The same things. The same things. Now, we can use this formula to find the quadratic function. For example, we're gonna use determine the quadratic function whose vertex is 1, -1, and through the point 2, 3. Okay, through the point 2, 3. So how to find the quadratic function where the vertex is 1, -1, and through the point 2, 3. How to find it? And we're gonna use this formula. We're gonna use this formula. Vertex. So we know h equals 1, k equals -1. Okay, because here I tells you the vertex. That means h equals 1, k equals -1. Okay, after you get h and k, then plug in this formula. We're gonna get what? Be careful. We plug in the x, h equals 1 plus 1, and the k is -1. Okay, you plus, you can write down like that. Plus x, k is -1. Right? Plug in k equals -1. Okay. So we can simplify it. Okay, that's good things. However, we still have one parameter is unknown, that is a. How to find the a? We can use this point. This point. What does that mean? When x equals 2, f2 equals 3, right? when x equals 2, the y value is 3, right? That means plugging the 2 here, you're going to get the y value is 3. That's the condition of this point, right? This point. So if you pick x equals 2, and you're going to get the y value is 3, right? So we're going to use this condition to find the unknown a, okay? So you just plug in the 2. So if you plug in the 2 for this function, equals 3, okay? Equals 3. That's the condition from this point, right? From this point, if x equals 2, y value equals 3, right? Plug in the 2, y equals 3. So that means we plug in the x equals 2 here, and the y value should be 3, right? What equals 3. So we get this one. Basically, we're going to solve this equation, right? Equation. So 2 minus 1 is 1. 1 square. So 1a minus 1 equals 3, right? And then add the 1 for both sides. You're going to get a equals 4, right? A equals 4. Then be careful. We plug in back. Okay, plug in back to this equation or this function. And we're going to get what? We're going to get fx. Okay, that's it. So that's the function for this is the quadratic function. That's what we want. Okay, what do we want? Okay, I'm gonna give you guys an example. Let you guys try it. Okay, try this one. This quadratic function through the vertex -2, -1, and through the point 3, 4. Okay, I'm gonna write down the answer on board. So be careful. The formula, right? I mentioned this formula. This formula has the vertex h and k, right? So for this guy, we have h, k, right? H and k. So what are you gonna do? And plug in the h and k in this formula, right? H and k. So fx equals a x minus h is -2, right? Be careful. Put a parenthesis there because here the h is negative. Okay, negative, then you put parenthesis when you plug in. And plus -1, okay? Plus k is negative, right? Put a parenthesis there in case you make a mistake. Okay, so you got this function. However, there's still one unknown. It's 8. So what are you gonna do? That means when x equals 3, y value is 4, right? That's the condition. When x equals 3, y equals 4. So you can plug in. When x equals 3, that means replace the x by 3. And the y value equals 4, right? So the idea is gonna be very simple. Just solve the a, right? Solve the a. So here is a 5 square, and 25a equals +1 for both sides is 5. Divided by 25 for both sides, and this guy will give you 1/5. Okay, and then you're gonna plug in back. Here we got the 8. Plugging back, we got fx 1/5. Okay, that's it. Now I'm gonna give you guys the last example. So now again, I give you the vertex that is 1, -5. And also I give you the y-intercept is -3. Okay, y-intercept is -3. That means what? For y-intercept, that means, any idea for the y-intercept? What is the y-intercept? What is the coordinate for the y-intercept? Is x equals 0, right? So this point should be 0 and -3, right? So that means when x equals 0, y equals -3, right? The same things. Basically express the same stuff like that, right? When x equals 0, y equals -3. So that means what? f0 equals -3, right? Is that clear? Okay, let's try it. Okay. Guys, please type your full name in the chat. I wanna check your attendance. Thank you. Type your name in the chat. Okay. Okay, I think most of you already get it. H equals 1, K equals -5. Right? So we plug in the formula. And then we're gonna get. Now, we need to use this condition to find the A, right? Find the A. So when X equals 0, Y equals -3, right? Plug in X equals 0 here, and Y equals -3. And we're gonna solve it. So -1 squared gonna be positive. And A equals what? A equals 2, right? A equals 2. Now you can plug in back, right? Plug in back, so we can get fx function. That's it, huh? That's it. That's the way we find the quadratic function. And in your MATLAB, there are some questions like what? There are some questions, find the maximum and the minimum of a quadratic function, something like that. Okay, so how to find this guy? That maximum and the minimum always about absolute maximum and the absolute minimum. If they don't mention any kind of local maximum, local minimum, that means absolute maximum or absolute minimum. So as I mentioned before, if I give you a function like that, okay, like that, for the first case, a greater than 0, we have curve opens up, and we have the vertex that is what? If a greater than 0, we have vertex like that, right? Then from the curve, we can clearly tell that is what? We have what? We have maximum or minimum. From this curve, we have maximum or minimum. Guys, if I give you this curve, do we have maximum or minimum?
Max.
Maximum?
No, it's minimal.
Yeah, very good. We have lowest point, right? For the maximum always goes infinity. We couldn't find the highest point. So we always have the minimum. And the minimum value should be this guy, right? The y value, right?
Excuse me, Professor Cody. So if the point is above the x-axis, is going to be maximum, or is it like?
We have the lowest point. You just find this point. We have from bottom to top. You have the lowest point, right? We have the lowest point here, right? But since the curve always goes up, we couldn't find the highest point. So there's no maximum.
Okay.
We learned such things before, right? Absolute minimum and absolute maximum. How to find the absolute minimum, absolute maximum? Find the lowest point or find the highest point. Here we only have lowest point, but we don't have highest point, right? Did you see it? We have lowest point. So this guy is the minimum. So for this case, we have vertex Now the curve opens down. So that means we have minimum or maximum? Maximum, very good. We have maximum because we can find the highest point. And the maximum always equals the y value, that is this guy, right? This guy. So that's what we learned before. I think 2 class before, right? We mentioned absolute minimum, absolute maximum. Okay, so we can see from these 2 cases, if a greater than 0, just draw this picture like that, and you can find the absolute minimum or minimum like that. If a is less than 0, just draw the curve opens down, and you can tell we have absolute maximum. Okay, now let's try this question from your MyMathLab. Okay, MyMathLab. Determine whether the quadratic function has a maximum or minimum. Then find the maximum or minimum value. Okay, so for this guy, we can tell that a equals 1 is greater than 0. Right? For this case, a is greater than 0. What are you going to do? Just roughly draw a draft. Okay, draw a draft. A is greater than 1. So it should opens up, right? A greater than 0 opens up. That means we have minimum value, right? We have lowest point. So we can determine that quadratic function has a minimum value. If a greater than 0, right, opens up, we always has the lowest point. So how to find the maximum and minimum? The idea is the same. Just find the vertex. Find the vertex, like we did before, right? Find the vertex. A, B, C. B is -4. A is 1, right? A is the 1. And then plug in the 2, right? So we have 2 squared minus 2 minus 5. Find the vertex, right? Find the vertex, and we're gonna get -9. Okay, so we can see the vertex that is what? 2, -9. Right? Vertex is 2, -9, and we can see the minimum value is -9. That's it. So the idea is find the vertex. Okay, draw the curve, find the vertex, and if you see the a is greater than 0, we have lowest point, and this value is -9. Right? That's it. That's it. And
Mr. Key, I have a question for you. Okay, you said a equals 1 is greater than 0. How did you get the 1 a equals 1?
You forget the coefficient, ABC?
No, okay, I remember that. But I'm just trying to. I don't know. Maybe I missed when you first written it down. But I'm trying to understand how could it be that a equals 1 greater than 0? I just can't see it.
The coefficient, right? The fx equals x squared plus bx plus c, right?
Right.
So coefficient of x squared should be a, right? What
Right.
is the coefficient of this guy?
1.
Okay, so a equals 1. B equals -4. C equals -5, right?
Oh, okay. So we never had to go through the B and C of it. We just only had to go through the A of it.
Yeah, I think you guys already know it, right? A, B, C, right?
Yes, I understand.
Okay, great. A is always about the coefficient of the x squared, right? A, B, C. Okay, so let's continue. Now try this one for me. The idea is very similar to find the vertex, right? Find the vertex. After you find the vertex, you draw the picture where you draw the draft of the graph, okay? Find the vertex, okay? You found it. Did you get the answer? What's the value?
The vertex is 1, 0.
You got the vertex is what? What's the coordinates for the vertex?
1, 0.
1, 0. No, I got -2. You make a mistake when you plug in the value. Be careful. When you plug in the 1, you need to be careful. It's 1 times negative 1 square, right? Okay, I'm gonna give you guys the answer. So it's very clear here, A is less than 0. That means what? This curvature like that, right? At least. So we have maximum, right? Maximum. That's what we can tell. If you draw a draft, right? If the curve opens down, that means there is a maximum. Now, the strategy is find the vertex. That is 1, right? Most of you guys already get it. Just plug in. The point is, what is this guy? It's -1, right? It's not like that. This negative is not squared. Did you see? That's the reason why I want you guys put a parenthesis there. Did you see it? Yeah. So if if we have -1 square, that means we do the square for the 1, nothing to do with the negative, right? If you put a parenthesis there, you do the square for the negative, right? Do you understand? Okay, very good. For this case, it's -1, right? -1. Okay, I'm pretty sure some of you guys have very bad habits because when you plug in the negative value, you always plug in like that. Don't put a parenthesis and you're gonna make a mistake, okay? You're gonna make a mistake. So for this case, you're gonna get -2, right? So now you can draw the more accurate graph. Is 1, -2. Okay, 1, -2, and we also know the curve is opens down, right? So 1, -2. We have the highest point, so the maximum is -2. Okay, I'm sorry. So we can draw the curve like that, right? Vertex 1, -2, and the curve is opens down. And we know the highest point is -2, right? -2. That's it. That's it. Okay. So the idea gonna be very simple. Find the vertex, right? And then draw the draft. Draw the draft with the vertex, right? If that is opens down, then you're gonna have maximum. If opens up, you're gonna have minimum, right? That's it. Okay, I'm gonna wrap it up across here. That's the end of all the material. Okay, that's the end of all the material. Thank you for coming.